Hello everybody, and welcome to another Visualization Network podcast. I'm your host Tom Crawford, and today's topic is the third part in a series, Well-Formed Data for Charts and Graphs. And today we're going to really dive into normalization. I know normalization is a bit of a geeky word and even a geeky topic. In fact, there's whole grad school classes on this. But really, if we want to get down and understand rule number one of making well-formed data, one concept per row, we really need to understand normalization. So often one of the concepts that will be in a row is a person. So we'll start with a person in this case. Let's call him Joe. Joe has friends, hobbies, places orders on the internet, has family. In fact, Joe has one and only one father. Now, of course, in this case we're talking biological, and there can be other uses for the term father, but in this case there's the possibility of only one biological father. In fact, it's really kind of hard to find one and only one relationships. If there is a one and only one relationship, you could have Joe in a single row in a spreadsheet. More often than not, Joe has many relationships, many friends, many hobbies. So in order to follow the one concept per row rule, we need to find a way to deal with relationships. So really, normalization is all about relationships. So for example, Joe places an order on the internet. But if you're running a business, you need more than one order to stay in business. In fact, you want lots of orders. So actually, Joe places many orders. In fact, all kinds of people place orders. So let's take a look at how you deal with that in a spreadsheet. So one simple way, one concept per row, the concept here is an order. You have one order, order number 420, placed on December 25th for $29, made by Joe. And here's all his contact information. And that's all fine. You could actually do some interesting graphs on this as you add more data. But once you add more data, it starts to be more problematic. Joe is ordered two more times, order 431 and order 435. Now that's fine. This data is totally usable for charts and graphs. It's standardized, it's clean, it's organized, it's consistent, follows all of our other rules, but it breaks the first rule of one concept per row. If Joe comes back and needs to change his address from 123 Main to 456 Park, we now have to change it in three places. Likely we'll miss one of them and we won't know which one to change. And then when we go to analyze the data is now inconsistent and becomes unusable or at least inaccurate. So how do we fix that? Well, what we need to do is really break the concepts into two sheets, because there are two concepts here. There's the order and the person. So we have broken the primary rule. So to fix that rule, we need to go back and have one concept per row. So we create two spreadsheets. First, a customer sheet. In this sheet, the only thing in each row is a customer. Each customer has been assigned a unique ID. We'll use this in just a second. Then we create a separate sheet for just our orders. So each row is only an order and only the order related information. Then we include the customer ID, 1, 2, 3, and then as customers return, the ID is reused. Now this becomes hard because these are just codes and you don't know what the codes mean. So Excel and many other programs that are similar have functions to help you deal with that. So for example, we can put in the customer last name. Now we know this is Joe Smith, and we could just type in Smith, but again that creates the problem that we're trying to avoid. So Excel has a function called lookup. In particular, we want the VLOOKUP. That's the most common one. There's also an HLOOKUP. Won't use that very often, and in this case the VLOOKUP is perfect for our needs, so that's all we're going to focus on. So the first question it asks is, what value do you want to look up? Well, we want to look up the customer ID, which is in cell B2. Then it asks us where we want to look it up. Well, we want to look it up on our customer sheet. And the final question it asks is, what value do we want returned? So in this case, we're actually looking for the last name just to make sure that we've got the right person on this order. And in that case, it's column C, which is our third column. So we type in a 3. And that is the end of our formula, and there it is. Smith is all set. So just to show what else we can do, we'll also do a VLOOKUP for their address. We're going to look up, again, the customer number on the customer spreadsheet, And in this case, the address is in column D, which is column 4. And there we go. Now the address is over. Now to check this, we need to copy it down. But before we copy it down, we need to put in the absolute values so that the row numbers stay the same. And that's just the $ ahead of the row range. So there we go. We can now copy this down. And there we go. Smith is in here with 123 Main in both locations. Now, just to show, if we go over and change Joe Smith's address from 123 Main to 432 Park, changed in this sheet, and we go over to the other one, and now it's changed in all 3 places. So our data is consistent and ready to use in charts and graphs. So that's the basics. We've separated out into separate sheets. So now that we've followed our rule, 1 concept per row, we have 1 order in a row, and it's only the order information, and 1 customer per row. So we've taken what was an ill-formed data set where it didn't follow the rule of 1 concept per row and broken it out into the 2 pieces. But it gets a little more complex than that. Orders is pretty straightforward. Joe can have many orders. Orders can have only 1 person purchasing them. But when you get to things like hobbies, it's a little more complex. Joe certainly does have many hobbies, and that would be one way to break it out. On the other side, though, hobbies can have many participants. So we have a many-to-many relationship. So let's take a look at a spreadsheet like that. So again, here are some people. The data is not well formed, so we'll have to clean up the data matching the other rules. But also notice that Sue and Tom have multiple friends and multiple hobbies. So how do you deal with that? Well, once again, we break them out into separate sheets. So we have a people sheet and we have a hobbies sheet. Notice that both of them have IDs. However, to connect them, we need a third sheet, the cross-reference sheet, or in this case, XREF, where each person's ID is linked to each of their hobbies. That way, multiple people can have multiple hobbies, and multiple hobbies can have multiple participants. So in this case, when you have a many-to-many relationship, you need 3 sheets to make that happen. The same could be true of friends. Joe does have many friends, but each friend also has many friends, and they're related to each other. So in this case, you would need only 2 spreadsheets, one with people and one that's a cross-reference. The cross-reference would link back to the original spreadsheet to pull any names or other information. So how far do you normalize? Well, you could go crazy with normalization, breaking things down further and further and further. The question you have to ask is, will the information change or will it expand? Do you create a separate spreadsheet for email addresses? Well, if there's an unlimited number of email addresses, then maybe. Or phone numbers, or addresses, or anything else. There's the practical side too, though. If the information isn't going to change all that often, or it isn't going to expand beyond a limited number, say 2, 3, 4 sets of information, then maybe leaving it in a flat spreadsheet might be okay. This is definitely an art and a science, and there's a lot more information that's a subject for a whole nother podcast. In the meantime, join me on the next podcast to learn about how to deal with missing data in the 4th and final segment of this series. Thanks, everybody, and we'll look forward to seeing you on the next Visualization Network podcast.